What if I told you that everything we thought we knew about dark energy might be completely wrong? The James Webb Space Telescope has recently made an astonishing discovery that could change our entire understanding of the universe. The idea that something terrifying existed before the Big Bang is gaining traction, and the latest evidence may have just confirmed it. In this video, we're going to dive deep into what the James Webb Telescope has uncovered and why dark energy might not be what we think it is. Stay tuned, because this revelation could be bigger than anything we've ever imagined. Einstein once described the universe as a bubble, our reality existing on the surface of this bubble, which is constantly expanding. This expansion is what we call the Big Bang. But string theory goes further, suggesting that there are many bubbles, a whole bubble bath of universes. And right now, Big Bangs are happening all over, creating new bubbles. So, what does that mean for our universe? Was there something before the Big Bang? Was it really the start of everything, or just part of something much bigger? Well, here's where it gets even more interesting. Yes, it is a Big Bang model, but recent discoveries suggest the Big Bang wasn't the true beginning. Something strange was happening before it. Scientists are now receiving astonishing images from the James Webb Space Telescope, revealing clues that challenge our very understanding of how the universe began. These new findings could upend everything we thought we knew. We've developed a pretty solid picture of how the universe evolved after the Big Bang, how the first stars, galaxies, and black holes came to be. But a massive question still remains: what existed before the Big Bang? The Big Bang has long been our answer to the beginning of the universe, but recent discoveries are leaving scientists stunned. Data from the James Webb Space Telescope suggests that something unusual may have existed before the Big Bang, exposing potential gaps in our standard cosmological models. So what exactly have we uncovered, and why has it shocked astronomers worldwide? Back in the 1920s, when scientists first studied distant galaxies, they made an unexpected discovery. Most galaxies appeared to be moving away from us. At first, some thought this meant Earth might be at the center of the universe. But further observations revealed something far more interesting. While most galaxies are indeed receding, others, like the Andromeda Galaxy, are actually moving toward us. This was puzzling at the time. Decades of research later, scientists figured out that it's not the galaxies themselves that are moving, space itself is expanding. This expansion has no central point, meaning that no matter where you stand in the universe, everything appears to be moving away from you, as if you're at the center. This mind-bending discovery led to the development of the Big Bang theory. But now, with these new findings from the James Webb Telescope, we may be on the brink of a revolutionary shift in how we understand the cosmos. Our understanding of the universe reveals something astonishing. There is no fixed center. Everything is moving away from everything else due to cosmic expansion. But there's more. Space isn't just expanding, it's accelerating. Recent observations have shown that 97% of galaxies in the observable universe are moving away from us faster than the speed of light. How is that possible when one of the fundamental laws of physics tells us nothing can travel faster than light? The answer lies in Einstein's theory of special relativity. It tells us that nothing can move through space faster than light. However, distant galaxies aren't moving through space. They're being carried away by the expansion of space itself. The space between us and these galaxies is stretching, making it seem like they're moving faster than light, but they aren't violating any cosmic speed limits. They're simply riding the wave of the universe's expansion. Scientists believe this expansion began with the Big Bang, the event that marked the birth of our universe. Before the Big Bang, there was no space, no time, no matter as we know it. The Big Bang wasn't just the start of our universe, it was the beginning of time itself. Here's a more engaging version of your script. When we talk about the Big Bang, we often imagine it as the moment the universe exploded into existence, a tiny, hot point expanding into the vast cosmos filled with stars and galaxies that we see today. According to our standard cosmological model, around 14 billion years ago, everything in the observable universe, and even what lies beyond, was compressed into a single, infinitely dense point known as the singularity. But here's the thing, this singularity wasn't just a small point in space. That would be the case if the universe were finite. However, if the universe is infinite, as it increasingly appears to be, then it was always infinite. The Big Bang didn't happen in just one spot. It happened everywhere, all at once. This means that the first galaxies didn't form in a specific region of space, they formed everywhere in the universe, even beyond what we can see today. Matter didn't just appear in one place, it came into existence across the entire cosmos at a particular moment in time. But while the Big Bang explains a lot about how the universe began, it doesn't tell the whole story. Have you ever wondered why the universe looks the same no matter which direction you gaze? Or why it appears so flat and spread out? If you take a telescope and look around, you'll notice that the universe seems remarkably uniform. This is where the concept of inflation comes into play. Inflation theory suggests that just before the Big Bang, the universe underwent a mind-boggling period of rapid expansion. In less than a trillionth of a second, it ballooned from a minuscule size to something vastly larger. This extraordinary growth was fueled by a peculiar form of energy present in what we once thought of as empty space. But this empty space was anything but empty. It was teeming with this special energy which acted like a cosmic springboard, pushing space to expand at breakneck speed. Before this rapid inflation, the universe was an incredibly cold, nearly empty void devoid of stars, galaxies, or even particles. Just a dark, cold expanse. Yet, this void wasn't truly empty. It held inflationary energy that stretched the universe out. During this expansion, any lumps or irregularities in space were smoothed out, giving the universe its flat and uniform appearance that we observe today on large scales. Once inflation came to an end, all that stored energy was suddenly released. This explosive burst of energy heated everything up and triggered what we now know as the Big Bang, a hot, dense explosion that filled the universe with particles, light, and the essential building blocks for galaxies, stars, and planets to form. The inflation theory not only clarifies why the universe looks the way it does, but also reveals that before the Big Bang, our universe was a cold, empty space that rapidly stretched due to this strange energy. This initial stretching laid the groundwork for everything we see around us today. While inflation explains many aspects of the universe's early days, it also brings up new mysteries. For instance, what triggered this inflation to begin and end? And what was this enigmatic energy that powered it? Recent discoveries from the James Webb Space Telescope have only deepened these questions. The telescope has made a surprising revelation. The universe is expanding at different rates in different directions. This is a significant finding because, until now, scientists believed that the universe's expansion was uniform. According to the theory of cosmic inflation, which posits that the universe underwent rapid expansion due to vacuum energy before the Big Bang, this expansion should have been the same everywhere. But if these new observations from the Webb telescope are correct, they could challenge our entire understanding of inflation. Why is the universe expanding unevenly in different regions? Could there be something beyond dark energy influencing this irregular expansion? Dark energy has long been thought to be responsible for the accelerated expansion of the universe, but these new findings suggest that there might be more at play than we previously understood. It raises the possibility that some unknown factor is affecting how space expands in various directions. Moreover, scientists are left pondering what else could be lurking in the cosmos, waiting to be discovered. The more we learn, the more questions we uncover, keeping the quest for knowledge about our universe as thrilling as ever. Here's a more engaging version of your script. Using the James Webb Space Telescope, scientists have spotted thousands of mysterious red dots in the deep field images it captured. Initially, they believed these could be distant galaxies, but the strange properties of these objects don't align with our current expectations for early galaxies. Their unusual behavior challenges our understanding and suggests there might be entirely unknown types of objects that existed in the early universe. These findings are significant because they hint at the possibility that something existed before the Big Bang. This could mean that very strange phenomena occurred before the universe we know came into being. Nobel-winning scientists and leading experts are now suggesting that our current understanding of the cosmos might be missing a crucial piece. While the standard model of cosmology effectively explains the evolution of the universe from the Big Bang onward, it falls short of addressing what came before. The new observations made by the Webb telescope imply that there's more to this story, something intriguing that took place in the cold, empty space that existed before the universe expanded. These discoveries open up a world of possibilities, urging us to rethink everything we know about the universe's origins and what might lie beyond the boundaries of our current models. Recent discoveries are challenging the traditional inflation theory, which claims that a rapid burst of expansion driven by vacuum energy set the stage for the Big Bang. If the universe was indeed shaped by this smooth, uniform inflation, then why are we observing signs that it's expanding at different rates in different directions? This anomaly suggests that something far more complex was happening before the Big Bang, influencing the universe in ways we're just starting to uncover. In addition to these expansion inconsistencies, the James Webb Space Telescope has detected strange objects in the early universe that don't fit within our current models. These intriguing findings imply that the early universe might have been more diverse and mysterious than we ever imagined. All of this evidence points to the possibility that the Big Bang wasn't the absolute beginning, but rather a transition from something else, something we still don't fully understand. As scientists delve deeper into these discoveries, they're becoming increasingly open to the idea that our current theories may need significant revisions. The notion of a pre-Big Bang era, where different forces or conditions shaped the universe, could revolutionize our understanding of cosmology. We're on the brink of uncovering a whole new chapter in the story of our universe, and the excitement of what lies ahead is palpable. Dark energy has been one of the most elusive concepts in modern astrophysics. It was first introduced to explain why the universe is expanding at an accelerating rate. According to current theories, dark energy makes up about 68% of the universe's total energy content. But here's the catch: no one has ever actually observed dark energy directly. Instead, its existence was inferred based on the motion of distant galaxies and the expansion of space. For years, scientists have been searching for definitive proof, but so far, it remains a mystery. Could it be that dark energy, as we know it, doesn't exist at all? Enter the James Webb Space Telescope. This groundbreaking piece of technology is designed to peer deeper into the universe than any telescope before it. With its powerful infrared sensors, it's able to detect distant galaxies and stars that formed billions of years ago, right after the Big Bang. In its recent observations, James Webb has provided scientists with unprecedented data about the structure and evolution of the cosmos. And here's the kicker: some of this data is starting to challenge the very foundations of dark energy theory. Could it be that our understanding of the universe's expansion is based on incomplete or even incorrect assumptions? Recently, the James Webb Telescope picked up something truly mind-blowing. Scientists found evidence suggesting that the universe might not be expanding in the way we've always thought. This revelation has thrown the entire field of cosmology into a frenzy. What's more, there are now theories that point to the existence of a mysterious force or entity that existed before the Big Bang, something that could have set the entire universe in motion. Some experts are even saying that dark energy might just be a misunderstanding of this pre-Big Bang force, something much more ancient and terrifying. For decades, the Big Bang has been the leading theory on the origins of the universe. But the new data from the James Webb Telescope has raised questions about what could have existed before this event. Some scientists are now exploring the possibility of a pre-Big Bang era, where an unknown force or entity, perhaps even more powerful than dark energy, governed the universe. This concept challenges everything we thought we knew about space and time. Could this mysterious force be the real driver behind the universe's expansion? And could it have been active long before the Big Bang even occurred? The discovery that dark energy might not be real, or that it could be part of a much larger and more terrifying cosmic force, opens up a whole new realm of possibilities. If dark energy is merely a misunderstood phenomenon, then the way we study the universe will have to be completely rethought. Future missions and space observatories may now focus on unraveling the mysteries of this pre-Big Bang entity. The implications for cosmology, and even for our understanding of reality itself, could be profound. We may be on the brink of discovering that the universe is far stranger and far more terrifying than we ever imagined. Dark energy has been one of the most elusive concepts in modern astrophysics. It was first introduced to explain why the universe is expanding at an accelerating rate. According to current theories, dark energy makes up about 68% of the universe's total energy content. But here's the catch: no one has ever actually observed dark energy directly. Instead, its existence was inferred based on the motion of distant galaxies and the expansion of space. For years, scientists have been searching for definitive proof, but so far, it remains a mystery. Could it be that dark energy, as we know it, doesn't exist at all? Enter the James Webb Space Telescope. This groundbreaking piece of technology is designed to peer deeper into the universe than any telescope before it. With its powerful infrared sensors, it's able to detect distant galaxies and stars that formed billions of years ago, right after the Big Bang. In its recent observations, James Webb has provided scientists with unprecedented data about the structure and evolution of the cosmos. And here's the kicker: some of this data is starting to challenge the very foundations of dark energy theory. Could it be that our understanding of the universe's expansion is based on incomplete or even incorrect assumptions? Recently, the James Webb Telescope picked up something truly mind-blowing. Scientists found evidence suggesting that the universe might not be expanding in the way we've always thought. This revelation has thrown the entire field of cosmology into a frenzy. What's more, there are now theories that point to the existence of a mysterious force or entity that existed before the Big Bang, something that could have set the entire universe in motion. Some experts are even saying that dark energy might just be a misunderstanding of this pre-Big Bang force, something much more ancient and terrifying. For decades, the Big Bang has been the leading theory on the origins of the universe. But the new data from the James Webb Telescope has raised questions about what could have existed before this event. Some scientists are now exploring the possibility of a pre-Big Bang era, where an unknown force or entity, perhaps even more powerful than dark energy, governed the universe. This concept challenges everything we thought we knew about space and time. Could this mysterious force be the real driver behind the universe's expansion? And could it have been active long before the Big Bang even occurred? The implications of this new data could be monumental. If dark energy doesn't exist, it could mean that our current models of the universe are fundamentally flawed. Scientists may need to revisit key theories and reevaluate how we understand gravitational forces, cosmic inflation, and even the nature of time itself. This could lead to a renaissance in cosmological research, spurring new hypotheses and explorations that redefine our place in the universe. The notion of cosmic expansion has long been a cornerstone of our understanding of the universe. But if the James Webb Telescope's findings are confirmed, we might have to reconsider how we interpret this expansion. What if instead of an expanding universe driven by dark energy, we are witnessing a more complex interplay of forces? This could prompt astronomers to devise new models that account for the observed phenomena, potentially leading to more accurate predictions about the future of the cosmos. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content, As a member of Blisovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.